Hello, my name is Hazai. I would like to talk about programming, security challenges, and solutions. What is programming? Computer programming, often shortened to programming, is a process that leads from an original formulation of a computing program to executable computer programs. Programming involves activities such as analysis, developing understanding, generating algorithms, verification of requirements of algorithms, including their correctness and resource consumption, and implementation, commonly referred to as coding of algorithms in a target programming language. Source code is written in one or more programming languages. The purpose of programming is to find a sequence of instructions that will automate performing a specific task or solving a given. Examples of computer programming languages. Some of the most famous ones are Java, which is used in Android, Objective-C, which is used in iOS, and some website coding, which is HTML. There are many types of programming languages that were used to program a lot of software, such as Android apps, iOS apps, computer programs, scripts, and many more. Security in programming is very important because it is the most basic level of security in a software. Programming security. Programming security is the practice of writing programs that are resistant to attack by malicious or mischievous people or programs. It helps protect the user's data from theft or corruption. In addition, an insecure program can provide access for an attacker to take control of a server or a user's computer, resulting in anything from a denial of service to a single user to the compromise of secrets, loss of service, or damage to the systems of thousands of users. Every program is a potential target. Attackers will try to find security vulnerabilities in your applications or servers. They will then try to use these vulnerabilities to steal secrets, corrupt programs and data, and gain control of computer systems and networks. Your customers' property and your reputation are at stake. Security is not something that can be added to software as an afterthought, just as a shirt made out of cardboard cannot be made secure by adding a padlock to the door. An insecure tool or application may require extensive redesign to secure it. Some examples of programming security are buffer overflow protection, format string attack, integer overflow prevention. This programming security protects the software from being broken by attacker. It limits the inputs from the user to avoid breaking the software. Buffer overflow protection. Buffer overflows, a common software security vulnerability, happen when a process tries to store data beyond a fixed length buffer. The overflowed data may overwrite other data, which can result in a security vulnerability, stack smashing, or program termination, segmentation. Format string attack. A format string attack is when a malicious user supplies specific inputs that will eventually be entered as an argument to a function that performs formatting, such as printf. The attack involves the adversary reading from or writing to the stack. The cprintf function writes output to stdout. If the parameter of the printf function is not properly formatted, several security bugs can be introduced. Integer overflow prevention. Integer overflow occurs when an arithmetic operation results in an integer too large to be represented within the available space. A program which does not properly check for integer overflow introduces potential software bugs and exploits. Top 10 programming security practices. Validate input. Validate input from all untrusted data sources. Proper input validation can eliminate the vast majority of software vulnerabilities. Be suspicious of most external data sources, including command line arguments, network interfaces, environmental variables, and user-controlled files. Hit compiler warnings. Compile code using the highest warning level available for your compiler and eliminate warnings by modifying the code. Use static and dynamic analysis tools to detect and eliminate additional design for security policies. Create a software architecture and design your software to implement and enforce security policies. For example, if your system requires different privileges at different times, consider dividing the system into distinct intercommunicating subsystems, each with an appropriate privilege set. Keep it simple. Keep the design as simple and small as possible. Complex design increases the likelihood that errors will be made in their implementation, configuration, and use. Additionally, the effort required to achieve an appropriate level of assurance increases dramatically as security mechanisms become more complex. Default deny. Base access decisions or permissions rather than exclusion. This means that by default, access is denied and the protection scheme identifies conditions under which access is permitted. Adhere to the principle of least privilege. Every process should execute with the least set of privileges necessary to complete the job. Any elevated permission should be held for a minimum time. This approach reduces the opportunities an attacker has to execute arbitrary code with elevated privilege. Sanitize data sent to other systems. Sanitize all data passed to complex subsystems such as commercials, the relation databases, and commercial off-the-shelf components. Attackers may be able to invoke and use functionality in these components through the use of SQL, command, or other injection attacks. This is not necessarily an input validation problem because the complex subsystem being invoked does not understand the context in which the call is made. Because the calling process understands the context, it is responsible for sanitizing the data before invoking the subsystem. Practice defense in depth. Manage risks with multiple defensive strategies so that if one layer of defense turns out to be inadequate, another layer of defense can